Hello and thank you for visiting the Danfoss Video Network. Today we're going to look at Danfoss's TR6 Thermostatic Expansion Valve. The TR6 is an air conditioning thermostatic expansion valve and is sold to many leading U.S. residential air conditioning manufacturers for use in their products. However, Danfoss has also created a version of the TR6 that is designed especially for aftermarket use and includes additional fittings to simplify installation. The aftermarket version of the TR6 is typically used for four primary purposes: to permit a contractor to improve the efficiency of a fixed orifice or piston residential system as an easy replacement for an OEM thermostatic expansion valve, to improve the efficiency when installing a new aftermarket evaporator cased or uncased coil, or to maximize system efficiency when replacing an outdoor condensing unit. The TR6 kit comes with everything needed for installation, including a valve, bulb strap, insulating tape, and the two most common types of evaporator fittings, Aeroquip and Chatlift. With these two fittings and the valves, the 3/8-inch ODF connections, the TR6 is an ideal replacement for most air conditioning thermostatic expansion valves. And the aftermarket version of the TR6 has a superheat spindle that can be adjusted when necessary to meet a system's needs. The power element is a result of Danfoss's 75 years of innovation in TXV design. We've identified the most common power element failure points and designed them out of the valve. Because we use stainless steel for its construction, the cap tube is less likely to break due to this metal's flexibility and durability, and the power element will not rust due to stainless steel's resistance to corrosion. Danfoss laser welds the power element rather than using plasma welding. Unlike other welding processes, laser welding directs heat only to the joint and reduces metal fatigue to the diaphragm, which means the diaphragm is less likely to fail prematurely. By brazing the power element to the valve body, Danfoss has eliminated the primary point of refrigerant leaks in TXVs. Also, a brazed power element prevents outside debris from coming into contact with the diaphragm, something very likely given the dirty environment in which TXVs are typically installed and serviced. Very small particles of debris have been shown to rapidly wear through the diaphragm, greatly reducing TXV lifespan. The superheat spindle is located on the bottom of the TR6 valve. Please keep in mind that superheat adjustments are rarely needed, as the valve is preset at the factory. Before an adjustment is made, allow the unit to run stably for 15 minutes to check subcooling. Superheat should not be adjusted until subcooling is in accordance with the manufacturer's specifications and unit contains the proper refrigerant charge. If a superheat adjustment is still required, use a standard refrigeration wrench to make adjustments. A full turn will produce about a 1-degree change in superheat for R410A and a 2-degree change for R22. Turning the spindle clockwise will increase superheat. Turning it counterclockwise will decrease superheat. Please note that when adjusting the superheat, the installer should only turn the spindle a quarter turn at a time and allow the system to run for approximately 15 minutes or until they see stable superheat before making any additional adjustments. The aftermarket TR6 also has a built-in check valve to permit its use in reversible heat pump split applications. This means the valve will only meter refrigerant in one direction and bypass refrigerant in the reverse flow. Selecting the right TR6 for the job is simple. You only need to know the system's capacity and the refrigerant being used. Each TR6 package clearly identifies the system capacity for which the valve was designed. The TR6 was developed with a unique MAH charge that limits migration and allows for slow opening and quick closing of the valve. This means the valve is less likely to hunt during changes in evaporator load, permitting the system to establish ideal conditions faster and reducing the chance of flooding the compressor with liquid. The TR6 also includes an equalization line to ensure proper function despite large drops in pressure across the evaporator and distributor, which are typical in residential AC systems. Barring any unforeseen complications, installing the TR6 is quick and easy. Let's take a look at a typical installation of a TR6 on an indoor A coil. First, pump down the refrigerant charge in the unit into the condenser or recovery cylinder. Next, disconnect the liquid line from the metering device and remove it from the system. If a piston is installed, as it was in our unit, be sure to remove it. Next, It's time to braze the outlet fitting you've selected to the TR6 outlet port. If the coil is equipped with a chatlift fitting that requires a Teflon O-ring, remove the O-ring prior to any brazing. In this case, our technician is loosely connecting the fitting to the distributor for stability during brazing. Be sure to wrap the body of the TR6 with a wet towel or use heat block paste to protect the internal components. Also be sure to keep the sensing bulb and capillary tube away from the heat. After brazing the female connector, keep the towel in place while you sweat the connector to the existing 3/8" liquid line pipe. Remove the towel, replace the Teflon O-ring if equipped, and tighten the outlet coupling. Now the sensing bulb and equalization port can be installed. The sensing bulb and equalization line should be installed on the suction line after the header. This unit already has the 1/4" male flare access fitting installed. Connect the tube to an existing access port or make a suitable connection by either brazing a port into the line or installing a copper T. Never install the equalization tube on the bottom side of a horizontal pipe as oil can clog this port. Now locate a horizontal section of the suction line and place the temperature sensing bulb on the top of the pipe. Locate the bulb between 10 and 2 o'clock position. Mount the capillary tube facing upwards using the patented copper strap included with the valve. Tighten the bulb onto the pipe. This will create a slight indentation into the suction line, which ensures excellent heat transfer. Completely wrap the bulb in all exposed ends with the insulation tape that is included with the TR6. This will ensure that the bulb is sensing the refrigerant and not any ambient temperatures. Now, with the TR6 installed, perform a leak check on all connections. After ensuring there are no leaks, you can properly charge the system, making sure there is the correct amount of subcooling. Finally, let the system run for 15 minutes for stabilization before checking the superheat. That's it. It's as easy as 1, 2, 3. Remember, the Danfoss TR6 valve's flexibility ensures that you'll always have the right valve for the job on hand. All you need to know to select the right valve is know the unit's refrigerant type, tonnage, and connection type. It's that simple. Keep in mind that Danfoss offers 2 convenient kits of these valves to ensure you always have the right valve for your job on hand. The first includes all 3 R410 TXV kits. The second includes all 3 R22 TXV kits. Thank you for watching our program on our TR6 thermostatic expansion valve. We hope that you now know just how easy it is to install. As the leader in expansion valve technology, Danfoss will continue to explore and discover new technologies to make your job easier.